So recursive functions are important set of functions. In mathematics, recursive functions are like this. N factorial n can be written as, okay, of course, one way to write factorial n is 1, 2, 3, 4, da, 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 n. Okay, this product up to n. But we can also write this as n factorial equal to n multiplied by n minus 1 factorial, or factorial of n minus 1. Okay, but this is not complete, because this will keep going on down and down. Like 5 is 5 times factorial 4, 4 factorial is 3, 4 times factorial 3. So it will just keep going down and down and down, down. So you have to break this. So to break it, you have to give when to break. So we say normally 1 factorial equal to 1. So keep going down, but you stop at 1 factorial. And that's where you just say that I don't go down, 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 but all the way, but I stop at 1. So this is allowed in Python, this kind of function definitions. So let's look at, so this is what I've written here, in fact, with this, but you need to write this as well. So there are two parts of the definition. For n greater than 1, n factorial equal to n times n minus 1 factorial, and 1 factorial equal to 1. So there's another there's another recursive object, it's called fractal. Okay. Now you must have, I'm sure all of you seen this. So this bigger triangle and is same as we say expanded version of a smaller triangle. If you look at a small triangle, of course the colors are different, but they are triangle within triangle. And the small triangle, if you expand it, it becomes like a big triangle. With here, of course, color conventions are a bit different, but these are fractals. Okay. Now we can make this stuff in Python. In fact, this image was produced in Python. Okay. So I will just show two examples. The fractal example is there in your notes. So so we do a recursive implementation of factorial. It's a pretty simple one, but the way we do in mathematics, we can just do the same in Python itself. So this is a function, factorial function. So def factorial n. So n is the argument. This is the function name. So we say the first the limiting case. If n equal to 1, then return 1. Else return n into factorial n minus 1. So factorial n, please recall, is calling itself. You see, is calling itself. But it is not the same argument, it is one argument less. So we have to give a path for the computer to converge, otherwise it will just keep going on and on. So we do this way. Okay, so what is the idea? So how does it work? So factorial 3 for n equal to 3, it will go down, and this condition is not true, so it will go here and say 3 times factorial 2. So this is what is going to be invoked in the computer, this one. Then next is 2 factorial. So it's going to go, this we are going to call factorial 2. So it's going to call the function. The same function will be called. So factorial 2, this 2 is not equal to 1. Then it will not execute this part, but it will go here. So this will be 2 times factorial 1. Okay. Now what is next? 1, so now factorial 1 will be called factorial 1. So it comes here. Then you say, this n equal to 1. So returns 1. It returns 1. And so factorial 1, the answer is known now. Okay, factorial 1 is 1. Now it's going to, so all the other calls were still waiting for it to be completed. So it has to complete this one. Right? I mean, it has called factorial 2. So now factorial 2 was 2 times factorial 1. So it substitutes the value of 1 here, and then 2 factorial becomes 2. Now this factorial 2 is going to be substituted here. Like 3 times 2 becomes 6. And that is what is going to be returned at the first time it was called. So this was returned 3 times factorial 2. And once this result is done, it just the function stops. Okay. So it is calling itself. We can just work out in a paper and pencil how this calls will take place. Okay, so call one after the other. So it first going down, 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 calls, but then this called back substitution. once the result is known for the limiting case, then it goes back. Okay. Now there's a nice puzzle called Tower of Hanoi. Now here the puzzle is that we have n pegs, n discs. Sorry, n discs. There are hole in the middle of the disc, and n discs are put on peg A. Okay, this peg A, it is all inserted like that. Of course, they are all different sizes. The idea is to transfer all the discs from peg A to peg C with the help of B. Okay. Now the rules are the following. You can transfer one disc at a time. You can't take all four of them and put it there. So one disc at a time. Rule number one. Rule number two is that a bigger disc cannot sit on top of a smaller disc. For example, I cannot put a small disc here, then put the bigger disc on top of the small disc. That's not allowed. So the smaller disc has to be sitting on top of a bigger disc. Okay. So that's the idea. Now the question is how to do it. Okay. Now it has both iterative and recursive solutions. The iterative solution is quite complicated, but recursive solution is very easy. Okay. So does someone want to tell me the solution? If you know recursion, then you can think. Okay, so let me tell the solution. I mean, so I know how to solve this problem for n discs. So I also can solve it for n minus 1 disk. Right? So I say, well, first transfer n minus 1 disk from A to B. So B is the intermediate disk, intermediate peg. So transfer this 3 disks to intermediate peg. That will be, of course, done by following the same rule. It is not that you put 3 of them one shot. You follow that rule. For this step, C becomes the intermediate. Okay. So the 3 disks. Okay, so I have it in picture. I transfer 3 disks to B, and the bottommost disk remains on A. Okay. So this is. So I'm reducing the problem of n disk to n minus 1 disk. And n minus 1 will do it with n minus 2 and like that. But okay, so now one disk is remaining on A. So what do I do with one disk? Okay, this can easily be transferred to C. There's nothing on C. So one disk can be put on C. Now, so this is a configuration. After step 2, this is a configuration. Then what do? I take these 3 disks. Again, following the same rules, I put on top of C. So put on this C peg. And that's it, I'm done. So I transferred n disks from A to C, but I had to do this intermediate steps. N minus 1 disk to B, and then 1 disk from A to C, and then n minus 1 to C. So that's it. So this is how you solve the problem. So when you do this n minus 1, you have to use C the intermediate, and is going to call n minus 1 will call n minus 2. N minus 2 will call n minus 3 until the disk becomes 1. Okay, so it calls, and then but your code will be simple code, but the computer will do all the dirty work. It's just keep calling one after the other. Okay, so let's look at the code, and then maybe I'll come back and just tell you 4 is slightly difficult, but how to transfer? Basically, just think of how to transfer, let's say 3. How will you do this 3 disks? Right now, I have to transfer 3 disks from. Okay, no, sorry. I transfer 3 disks from here to here. So what should I do? I'll call first. Take the 2 disks on top. It's going to call 2 disks, but it is not transferring to B. 2 disks has to transfer where? Intermediate will be C. So first transfer 2 disks to C, then 1 disk to B, then 2 disks from C to B. Okay, that's how we transfer this 3 disks. Now, how will you transfer 2 disks? So transfer will be again, you use the same step 1, 1, 1 like that. Okay, so it is done in that way. So the computer will do that all that work. going from n minus 1 to n minus 2, n minus 2 to n minus 3, and so on. So these are function definition. That's it. It's 6 lines. So def tower of Hanoi n. Now, of course, you have to write this. You can't say A to C, okay? Because the intermediate will keep changing. So say source is from where you start to where you want to go, where you want to take the disk, all of them, and intermediate. So intermediate is intermediary. Okay. Now the answer is the structure of the function is if n equal to 1, print transfer disk. Sorry, this is only one disk, so I can give the solution right away. From source to 2. Okay, intermediate I don't write. So, but if it is not equal to 1, then tower of Hanoi, call the same function with n minus 1 disk, but go from source to intermediate. Remember, I transferred n minus 1 from A to B, not to C. A to B, but the destination becomes an intermediate peg. So 2 becomes intermediate peg. Now we have, well, 1 minus 1, n minus 1 has been transferred to intermediate. Now you take the bottommost disk and transfer that from source to destination, because there's only one disk and destination is empty. There's nothing on the destination. Then take n minus 1 disk from intermediate, which is right now was a B disk, and put it on C. Okay. Now source becomes, in fact, the A peg will be the intermediary for this case. Okay. And this function works. I can work it. I can tell you for what happens for 3. So this is a set of sequence of steps. So first you take A to B, then A to C, then B to C. So if you just follow this, these are available in the market, but you can make your own 3 disks. You can take piece of paper or cardboard, and you can just do it. It works. Okay, you can do it for 4, 5. So how many steps does it require? If somebody knows the answer, he can tell me. I prove in the notes. The number of steps required for n disk is 2 to the power n minus 1. Okay. So for 3, it is 7 steps. 2 cube minus 1 is 8 minus 1 is 7. So it is indeed 7. Okay. For 4, it will be 15. Now, what if it is 64? 64 disks sitting on top of each, sitting like stacked. Now, how many steps will be required? Is 2 to the power 16 minus 1. And what is the 2 to the power 16 minus 1? So, 2 to the power 64 minus 1. I'm sorry, 2 to the power 64 minus 1. So, how big is the number? So, the way to estimate is the following. So, you write this as 2 to the power 60 multiplied by 16, right? 2 to the power 4 into 2 to the power 60. So, that makes it 2 to the power 4 is 16. 16 times 2 to the power 60. Now, 2 to the power 10 is 10 cube, roughly. Not exact, but equal, approximately. So, 2 to the power 10 is 10 cube, which is 1000. But now 2 to the power 60 will be 10 cube power 6. So it's 10 power 18. Okay. So the number is 16 times 10 power 18 minus 1. Okay, minus 1 you can ignore it. So this is a huge number. 10 power 18 is exa. So you have 16 exa. Now even if you take 1 second to transfer one disk at a time, in one shot, this is going to take something like age of the universe. So it is a very large number. So there is a myth. So there is a priest sitting in Banaras who has a 64 discs, and he's transferring it from, like, the objective is to take from A to C, and once this is done, the universe will end. Okay, so that's the myth. But of course, the idea is that it just takes a very, very long time to do this. Number of operations become very large. It's exponential operations. Huh?